'Cause I'm in the stars tonight. So watch me bring the fire, set the night light. Shoes on, get up in the morning, cup of milk, let's rock and roll. Kink out, kick the drum, rolling on like a rolling stone. Sing song when I'm walking home, jump up to the top of the brown. Ding dong, call me on my phone, nice tea and I'll get my ping pong. This is getting heavy, can't hear the bass, boom, I'm ready. Life is sweet as honey, yeah, this beach chain like money. This go overload, I'm into that, I'm good to go, I'm diamond, you know I glow up. Hey, so let's go. 'Cause I'm in the stars tonight. So watch me bring the fire, set the night light. Hey, shining through the city with a little funky soul. So I'ma light it up like dynamite. Whoa, bring a friend, join the crowd, whoever wanna come along. Word up, talk, just move right up the wall. There night, sky's the light, so we dance to the break of dawn.
Ladies and gentlemen, I got the medicine, so you should keep your eyes on the ball.
This is getting heavy, can you hear the bass? Boom, I'm ready. Levies, sweetest honey, yeah, this bitch chain like money.
Hey, what's up, math friends? How's it going today? Welcome to another wonderful day of online learning. Today we will be talking a little bit more about one variable statistics and a new operation that we can do called the standard deviation, which will prove how far things are away from the normal set of data. So that's actually kind of the theme of our discussion today. One thing I wanted to talk about real fast is different types of box plots. When we see a data set, right, and it's represented by that graph that we used the other day, we can have a few different types, right? This over here, everything's about like 25%, right where the quartile should be. That's going to be a normal distribution bell curve, right? If, however, we have all of the numbers scrunched down at the end, what that means is this point over here at the top that's all by itself is probably going to be like an outlier. An outlier is a data point that is way far away from the normal range, right? So like, for instance, Mr. Cartwright can run about a 12-minute mile, but Usain Bolt can run a 3-minute mile, right? So like, they are way different from each other, right? I am on one outlier of being slow and lazy, and he is much, much faster than me. The other thing I wanted to talk about today is the range. The range is the distance from the maximum point to the minimum point. Or in other words, you just subtract max minus min to get your range value. I'm just going to move that a little bit over. All right, so a couple of different box plots. If all the numbers are chunked in the middle, that means you have outliers on either end, right? And let's talk about that too. So we have different types of bell curves, right? A normal distribution is why it's called a bell curve, because it kind of looks like a bell. That means whatever sample you take, and it's kind of a cool principle in statistics, doesn't matter what you're looking at, most of the time you're going to get a normal bell curve. The vast majority of things, over 75%, are going to be right in the middle there, very close to each other. And you're always going to have outliers too. So whether you're looking at height or number of apples on a tree, you're always going to probably get this normal bell curve distribution. There are times when you don't, and that is usually implying something that is true about the world, right? So if you have a bell curve that is like this, you, in science, let's say this is a certain trait, right? If everybody has brown feathers, right? We're birds in this analogy, right? And if everybody has brown feathers, that might be better suited to survival. The people that are over here with different colored feathers might get eaten by predators. We're gonna go ahead and erase that one. Okay. So the interquartile range describes the range from the first quartile to the third quartile. So basically, the end of the first quartile subtracted from the third quartile will give you your IQR, or your interquartile range. It is basically right here, and it's where the majority of the numbers should lie. So yeah, you take your quartile for one number, you subtract your quartile 3 number, that gives you your interquartile range. And that is important because of the standard deviation. The standard deviation implies how far away you are from normal. So normal, right, would be anywhere in that first standard deviation. 1 unit away would be considered normal. That would be 68% of the population would fall within that range on a normal bell curve. So when you get on your NWA, if it says you're in like the 90th percentile, what that means is you're way over here on the bell curve. Specifically, you're like right here, right? And the bell curve stretches all the way out, right? Like there are outliers that are even further. But we can talk about like how different something is based on how far away it is from the mean, how many standard deviations it is away, right? And each of these standard deviations is an even chunk, right? You see how they're evenly distanced on the graph, and there is a way to calculate that. So if you wanted to calculate the standard deviation, what you would do is you would take each number and you would subtract that number from the mean. So you subtract the number from the average, right? Square it and add them all together, right? So we are taking the average distance from the mean, if that makes sense. So you take each number, you subtract it from the mean, you add them all together, square them, divide by the total number, and then take the square root, okay? So let's do that for a set of data, right? I picked easy ones because I'm lazy. 2, 4, 6, 8, 10. My mean is 30 divided by 5. Added them all up, divided by 5. Mean is 6. So I'm going to take each number and subtract 6 from it, right? So we got 2 minus 6 squared plus 4 minus 6 squared plus 6 minus 6 squared is 0 plus 8 minus 6 squared plus 10 minus 6 squared. Fun times, right, that we have in math class. We would do all of this, divide it by the number. We got 5 numbers up here, so we're going to divide it by 5. And then finally, we would take the square root of that monster to get to what 1 standard deviation would equal. In this case, 1 standard deviation I already know is equal to 2. 1, because I used a very simple data set, right? That's 1 away, that's 2 away, right? 1 away, 2 away. It divides out evenly really easily because of the data set I used. But if I went through and did this calculation, which I don't want to or have time to, it would even out to 2, right? So 1 standard deviation would be 2, and 66% of the data, or 3/5, would be contained between 4 and 8. There are calculators that do this a little bit faster. Other than that, we will have to brute force and do some of these calculations on our own using that method. So once again, you take the number, you subtract it from the mean or the average, and then you square it. So we are taking the distance from the average squared. We add them all up and take the average of that and take the square root. And we're going to practice it a little bit so that we have, that makes sense. Please now return to the live classroom if you have any questions. Thank you.